All right, Algebra 2. Here we go, guys. Section 3 today, Chapter 8. This is all about adding and subtracting rational numbers. So up to this point, we've dealt with some multiplication, some division, and to be honest, that's been a lot of review concepts that I know are covered in Algebra 1. But this section is a little bit new. There's some similarities. But as far as things being new, you want to pay close attention. And you're going to see, we'll zoom in here. Don't scamp, all right? Write everything down. If you guys are doing, like, here's the original problem, and then boom, here's the answer for every single thing on this assignment, there's just no way, all right? So you have to show everything. Don't magically forget to bring your work in when this homework is due. So show all your steps, be diligent, be very specific, be precise, all those things. Okay, so yes, remember the basics. That was me talking at the very beginning, all right? You need common denominators when you're working with fractions and adding and subtracting. That's kind of obvious, but when your common denominators are not simply just a number, then it becomes a bigger concept. Okay, so pay close attention, especially when they're asking you to do things like this. Find the LCM, least common multiple. All right, so a lot of times you're going to have to factor things, factor them completely, simplify them, get them down to their basic binomials, and then look, as they're going to say here, for all the common factors. Okay, find those common factors, and if you don't have them, then you have to create them, all right, which you'll find in these notes. And when you have powers, use the highest power to find those common factors. All right, I think that's enough of that. Let's just jump into some example problems. All right, let's get into it. So here we go. First one. You're going to notice that we do have common denominators, all right? 3x minus 1, 3x minus 1. That's good. This is kind of our baby steps into it, all right? So in this case, if we already have common denominators, which we do, then you can immediately start to simplify the numerators, all right? Which you're going to see a minus sign here that is going to be distributed to all three parts of that trinomial that's just to the right of it. Okay, you're not going to distribute it to both sides. You're only taking this negative and distributing to everything to the right. All right, so let's do that. Let's show what that looks like after we have that. So the 3x squared minus 5, that stays. And we'll try to get the screen just right here. All right, so 3x squared minus 5, then minus 2x squared, going to be a plus 3x and a plus 2. All of this is going to have the 3x minus 1 below it. Okay, so plenty of space here. Now find your like terms. Okay, so we're going to have some like terms, the 3x squared and the negative 2x squared. All right, these guys are just going to become x squared. Then let's look for anything else. We have a 3x. I don't see anything else with just a regular x, so that's plus 3x. And then you have a plus 2, but then you have a minus 5. So that's going to give you a minus 3. And then let's see, all of this again is just going to be over 3x minus 1. Okay, and if you take a look at that numerator, x squared plus 3x minus 3, that is not capable of being factored, okay? Because if you take 3, it's a prime number. You just create 1 and 3. 1 and 3 cannot actually create the number 3 again. if we're talking about addition and subtraction. So I know I'm just kind of verbalizing how you would think through, does this factor or not? This does not factor. So in that case, this is our answer. This is the simplified version of our answer. But if you are going to look at the directions in your homework, they may also say, and then specify what x value would make this undefined. So to make any fraction undefined, that would mean you have 0 in your denominator. So if we look at that, 3x minus 1, if we set 3x minus 1 equal to 0, then we would determine what x value our answer could never be. Okay, because if x were to equal that, which if we just jump ahead and take a look, x cannot equal 1/3, that would be me taking 3x minus 1 and setting it equal to 0, and then solve that. Solving that, you get 1/3. So what we would then say is x can't equal 1/3, because if it did, then our denominator would be 0. And if our denominator is 0, the entire fraction would be undefined. That's not good. So really, we would need both parts here. Okay, there you go. So let's take a look at example problem number 2. LCM, least common multiple. And what you're actually looking at, even though it kind of think it's a little backwards here, you hear the word least, you think it's got to be smallest, but being that I just said it's backwards, you're actually looking for the biggest possible thing that they could both fit into perfectly. Okay, well, let me rephrase that. It's a number bigger than, for example, 3 and 4, but they both fit into it. It's the smallest bigger number. I know it doesn't seem to make any sense here, but follow along with me. You'll get the logic as we do it. Okay, so as I just said, what is the smallest but bigger number that 4 and 3 can fit into? And it's 12. Okay, now if you want to figure out a little bit more of an expanded way to do it, you could think of a factor tree. Remember doing those? And I'll do a little one off to the side here. If we were to do 4 and 3, 3 is just 3 and 1. It's prime. But 4 is 2 and 2. Okay? So if you were to take all of these numbers and multiply them together, you would get 12. Okay? So in that case, just kind of wanted to show you that's the logic behind it when you do your little factor trees. But what if we have exponents with variables? Then what you're looking for is, for starters, the common variable. So focus on here, we have x and there's an x. What's the biggest exponent that they give us? That is our least common multiple. So x to the power of 3, x to the power of 5. The least common multiple of that one, sorry, let's go back and get it to the same color here, is going to be the 5. So the LCM for x to the 3rd and x to the 5th is the bigger number. Use x to the 5th. So using that logic, if you have y to the power of 7 and y to the power of 4, what's the bigger exponent? We're going to use y to the power of 7. Okay, so that covers our least common multiples for number 2. What if we got a little bit more than just regular old numbers with exponents? We have full polynomials. We got a binomial in x squared minus 4, and we have a trinomial in x squared plus 5x plus 6. Factor them. Step 1, factor them. Okay, so this side is going to factor into x plus minus 2 and 2. How do I know that so quickly? Because it's a perfect square binomial. We've talked about this in past videos. X squared is a perfect square. 4 is a perfect square, and it is subtraction. So it fits all three parameters. Okay. Now let's factor the trinomial. All right, we have x, we have x. Notice both are plus signs. So in the parentheses, both will be plus signs. Numbers that are factors of 6, that when you add them together equal 5, and it would be 3 and 2. All right, 3 times 2 is 6. Perfect. That's what we're looking for here. 3 plus 2 is 5. Perfect. That's what we need right there. So now what you are looking for is you're looking for what they have in common, which in this case, they have the x plus 2 and the x plus 2. Those they have in common. So I will be bringing one of those down into my LCM. All right, so x plus 2. If they have it in common, only bring the 1 down. But you'll notice we do not share x minus 2 and x plus 3. They don't have those in common. And if you don't have them in common, you must bring them both down. All right, so x minus 2, x plus 3. All right, this is your least common multiple. Again, I'll say if they share them, if they have terms in common, in this case, they both have x plus 2, bring only one of them down. But notice they don't share x minus 2. You must bring it down. They don't share x plus 3. You must bring that one down. Okay, that's how you're creating your LCM. All right, let's work out another one. Now it's a full-on, let's use addition. We don't have common denominators, so we're going to do a little bit of basically the last 3 problems all put together. All right, we got to find LCMs, we got to get common denominators, we got to simplify the numerator, the whole process. Okay, so let's work this out. All right, the x over x plus 3, I can't simplify any of that. But I'll tell you what I can simplify is this denominator. All right, I want to focus on simplifying that denominator because it can be factored. All right, so let's factor that. This factors down into x plus 3 plus 3. Okay, 9 is created by 3 times 3. 6 is created by 3 plus 3. You'll notice that we are sharing one of these guys, right? But this guy has 2 of them. So that means that our common denominator in this case is actually going to be 2 of these guys. Now, how can I put an extra x plus 3 over there? I have to multiply it by that. So just like you did with basic fractions, you have to multiply the other side by what it doesn't possess. All right, so now comes all the work. Let's expand this out. So x over x plus 3, but we are multiplying the top and bottom by another x plus 3. This side is not changing because this side already possesses the common denominator with the x plus 3, x plus 3. All right, so use the distributive property here. And I'm going to give you a nice hint. Don't combine these guys back together. You can leave them separated. Just showing x plus 3, x plus 3, that's totally fine. All right, so let's combine. And what we're going to have on top now is x squared plus 3x plus 2x plus 6. All of this is over the common denominator, x plus 3, x plus 3. What you should see here is I distributed the x. That's how I got this part right here. Then I just tagged in the 2x plus 6. That's how I got this part right here. Now we have like terms right there that need to be combined together. x squared plus 5x plus 6. And then our denominator x plus 3, x plus 3. All right, we are almost there, but we're not done yet. Why? Because we have a numerator, this trinomial, that can be factored and then broken down. Okay, so let's do that. It will factor to x plus 2, x plus 3, our common denominators. Now you should think back into some previous sections because we can take these guys out. All right, notice everything from here is now multiplication and division, which means we can start to simplify things and cross terms out, which means what we're left with is this right here. That is our solution. X plus 2 over x plus 3. And then if I ask you the question, what can x not become? What can x not become? And you got to think back. What would make my denominator equal to 0? All right, and we would say x cannot equal -3. Think about that. If x were -3 and we plug that in there, -3 plus 3 would give me 0. 0 in the denominator gives me undefined. Undefined is not good. All right. Number 5. All right, here we go. Okay, we don't have anything that we can simplify right here. So we immediately have to go and start figuring out what's my common denominator. Okay, and I'll tell you, 2x plus 5 cannot magically become 5x minus 2. And vice versa, 5x minus 2 can't become this side. So we have to immediately jump into multiplying both sides by the opposing side's denominator, all right, the opposite. So we're going to multiply top and bottom here by 2x plus 5. And we're going to multiply the top and bottom over here by the 5x minus 2. Okay, so we got some expanding out to do before we can simplify it down. And I'll tell you, your denominator, it's totally fine to just keep it as 5x minus 2 in parentheses and 2x plus 5 in parentheses. That's going to help us out. Okay, so let's start to distribute here. And don't forget, that negative sign goes with that 2. So the negative has to go somewhere. The negative goes with the 2, all right? So think of that. That's a -2. And we're going to have to distribute that -2 into both parts here. And then we're doing a little bit of a double distributive property on this side. And let's work all that out and then condense it down, okay? So here we go. We got a 5x and a 3x. That's going to give us a 15x squared minus 10x. And then you got a -2. It's going to give you a -6x. And then that's a +4. So everything that I did here came from this right here. Now the opposite side, we're going to have a -4x and a -10. All of this is over a common denominator of 5x minus 2, 2x plus 5. Okay, now comes the find your like terms, combine like terms. Okay, -10x, -6x, -4x. This seems pretty good. All right, we have a -6 and a -4, making another -10 and another -10. All right, so we're gonna change the color here. Let's drop it down. So we have a 15x squared minus 20x. And then we have another like term. Don't forget you have the plus 4, the minus 10. That's going to give us a minus 6 all over the same two terms. In our denominator, 5x minus 2, 2x plus 5. Okay, let's keep working this out here. All right. Okay, and looks like, according to the good old book here, I actually can't go any further. So, praise the Lord on that. We don't need to go any further. This is as far as we can go, okay? But as the book has been asking, what will the denominator not be? What can x not become? Remember, if x becomes these numbers, it makes it 0. 0 in the denominator, undefined. We don't like that. So what you have to do is you have to take these individual binomials, set them equal to 0, solve them. What will that give you for your answers? That means x cannot equal 2/5, and x cannot equal -5/2. So here's every single piece that you will need for that problem right there. Okay, so what you're looking at, simplified polynomial and answers that x cannot equal in your denominator. All right, last problem, complex fraction. Here's the hint. Simplify each part, then use KFC. KFC, keep, flip, change. This goes all the way back again, Algebra 1 stuff. Okay, let's start to simplify what we can. Notice x plus 1, can't simplify it. Can't simplify the entire denominator there, but we can simplify that, x squared minus 1. So let's do it. So x plus 1 is going to be over perfect square binomial. That's what this is. Perfect square x squared, perfect square 1, and its subtraction. X plus 1, x minus 1. This entire fraction is then over x, x minus 1. Why did we simplify? Because we could already start to cross things out. That's why x plus 1, x plus 1, that's gone. Before we even did KFC, we were already starting to simplify. Okay, so now let's rewrite this. This in the top is going to have a 1 up there. Okay, so it's going to look like 1 over x minus 1. That's what we're going to keep. Then we're going to flip the bottom and multiply it. X minus 1 over x. Okay, so what I did was I took this and I flipped it and it became that. Now we get to cross even more out. This is an easy, very nice. X minus 1, gone. Simplifying it down to just 1 over x. Very nice, very neat, very simple right there. And that's as far as they want us to go for complex fractions. All right, so let's zoom out a little bit. There's all the work for number 6. Okay, and then we'll scan up here. Here's all the work for 2 through 5 right there. And there's everything on number 1. All right, you guys got this. Ask questions, pay attention to all the little steps, write everything down, ask me questions if you got them. All right, we'll see you guys in the next one.